So relationships between the graphs of f and f prime. So since the derivative at any point is equivalent to the slope of the function at the point, we can estimate what the original function looks like when we're given a graph of the derivative and vice versa. So example 4, we're going to be given the graph of f, and we're going to be asked to sketch the graph of the derivative on the same axes. Alright, so what I'm going to do is I'm going to look for my slopes. So I see that this little piece, where's my highlighters? That little piece has a slope of 1. Sorry, excuse me, -1. I forgot my next piece, if I count that out, that has a slope of -3/2. My next piece has a slope of 0. And then finally, this piece has a slope of 2. Alright, so now I get to go graph this. So slope of -1, I'm going to go to -1, and I am just literally going to graph my slope. Well, my slope the whole time is a constant of -1, so that's exactly where that y value is going to stay. Alright, I guess I shouldn't put the arrow on because I don't know if that's continuous after that. Alright. My next bit has a -3/2 slope, so -3/2 is -1/2. I'm going to include my point here. I could have included it up there. It really doesn't matter which one you include it on, as long as it's only included once. And my negative slope continues all the way until my x value is +1. And why not? I'm going to include it here as well. I don't have to. My next bit slope started at the x value of 1, and my slope was 0, so my x value is still going to be 1. My y value is going to be 0. And that goes all the way until x equals 3. And then finally, my last piece has a slope of 2, where my x values was 3, so I'm going to pick that back up at 3. I'm going to go and find my y value of 2. This one's going to get shaded in because I have to include it once. And then it's going to go all the way till over here. And it's going to have filled in circle. Ta-da! There's my slope. Cool. My next one's a little bit harder to just tell the slope in certain places. But I know my slope at the top should be 0. Alright, so my slope at 0 should be 0. Alright, and then I see my slope here is about -1, to be honest. So I'm going to go plot that point. Likewise, I see that my slope over here is about +1. And then my next bit, I would have, okay, I need to see what my slope is here. Well, I see that my slope there is about -2. And likewise, on the other side, my slope at that particular bit is about +2. And so we might see that this trend is starting to look more and more and more and more and more like a line. That's because it is, and hopefully you guys can make lines a little bit straighter than I can. I'm gonna just keep trying. Alright, this one's a lot better than the first one. And that's true for any quadratic. Any quadratic's derivative should be a line. Alright, so if you're freaking out about this, don't yet. We're going to be doing a lot of work with it. That's about all for now. I'll see you in the next video.